morning, everyone. And I can say that this morning with confidence because I know it's still 11:30 in Newfoundland, or just slightly past 11:30 in Newfoundland. Thanks for taking the time out of your busy day to spend with us here at Viessmann. Today, we're going to have a look at the Vitodens 100, our new products, the B1HE and the B1KE boiler. We've done some presentations over the last month or so, some wholesaler training. We just finished a block of 200, 100 overview training as well. So if you haven't taken any of that in, it's been archived on our YouTube channel. So have a look at that. That gives you a nice broad overview of these new boilers and what we have to offer you here. We're going to look at a specific kind of topic there, how to apply these boilers to your jobs, whatever you might have out there, and go through the different features of them and how to install those boilers once you decide that that is the right fit for your particular applications that we have out there. Joining me today are Mark Norris and Curtis Scharholz out of our Waterloo, Ontario office. So today your guys are getting a 3-for-1 deal. So the price of 3, for the price of 1 Viessmann Academy instructor, you're getting 3. Good morning, gents. How are you guys doing?
Good. How are you, sir?
I'm doing well. It's a little early in the morning here on the West Coast, but
yeah, I was going to say that. I was going to say Scott's got up really early to do this because it's only like 7 where you are, right?
That's right. My oatmeal's still sitting here, still warm on the table here as I'm talking to you guys. So it's breakfast time for me. Yeah.
Start with the coffee.
I had a few of those already this morning. So yeah, always a help. Yeah. Set the stage right. So these guys are going to jump in whenever they feel appropriate and kind of help.
We have to wake you up a little bit when you nod off.
Every once in a while, just a little nudge here and there. There's no cattle prod here. You guys are too far away to do that. So
that's right.
Just a gentle nudge would be nice. And so just to kind of, like I say, we're just, any questions you guys have out there, these guys are ready to answer them.
If you have questions, put them in the Q&A box, which is at the bottom of your taskbar. Don't use the chat because we can answer questions in the chat, but if we answer them in the Q&A, we can keep a record of it, and there will be a PDF of all the questions and answers at the end, put with the PDF of the presentation. So ask them the Q&A. We'll answer them in real time if we can. If there's something Scott has to deal with near the end, we'll do that.
Sounds fair. Let's get right into it. So we got a couple hours here, I think, to work through, and we want to maximize that time. So we'll get right into this application installation training here today. So this is a slide from the overview that has been going on the last couple of months, and some of the goals that these boilers, what we were trying to achieve here with these new products, is not just to bring out a new boiler, but just a whole array of also digital tools that are going to accompany this particular unit. Everything from the planning stages of your boiler, when you just, like the first time you show up on the site, and you're kind of identifying, the needs and the desires of the application, right straight through to the final commissioning and onwards after that into the service. We have digital tools that are going to apply to all those things, including the homeowner. So there's a VI plan or V plan tool that we have, which will take you from the start to the finish, which will be rolled out. And we'll have training on these different tools. We have a vCare for your homeowners to basically communicate with their boiler remotely, whatever they need to do with their unit to stay in touch, to optimize their comfort, and of course to save as much fuel as they possibly can by looking at what's going on in their system. And for the contractors and for our Viessmann tech people, we have the Vito Guide app, which will help us do things like commission the boiler, as you're going to see in a couple weeks when we do the startup and commissioning training going on, as well as troubleshooting the boiler remotely. So different information there, which are going to save you both time and money, as far as things like gas going back and forth to job sites to have to do things like touch a button to change a little value or whatever. So lots of digital tools that accompany these boilers. So it's not just about the boiler, it's about all of those apps that are available as well. So it really makes a powerful device that we're going to deliver to you here in the near future. Along with the digital tools and the Wi-Fi boiler, you still have that human to machine interface. So basically standing in front of the boiler, you've got an interface there that is really easy to use. Information is in really nice little packets. Whether you're looking at burner information or domestic information or spacing, it's all sitting in there and usable information. So stuff that you want to look at, set points and actual temperatures, that kind of stuff is all there to help you make sure that things are operating and utilize that powerful device to your advantage there. So lots of good information on that. We've also gone to great lengths here, the engineers at Viessmann, to reduce the number of spares. So when you look at these boilers, you take away the control on the front of the boiler here, basically the burner, the heat exchangers, flue gas collectors, all those things are uniform across the product lines for the basic sizes. So if you're looking for an igniter, for instance, on a 100, it's going to be the same as the igniter on the 200 you're going to come to look at. So sometime in the near future, we'll be doing a service seminar, and we'll go through a lot of that stuff in a much more detail. But we've reduced the spare parts, even to the point where the control on the front of this boiler is actually universal for things like heat pumps, et cetera, in Europe. So we've gone to a great detail there to really reduce the platform size right across the whole portfolio. Which means savings, because now that reduces the economies of scale, and of course, as far as the price points, all that stuff becomes a little bit less expensive, and we have a larger volume of those components being manufactured. Simplification in service and commissioning, basically with the HMI on the front of the boiler and/or using the digital tools. Very simple walkthrough of commissioning now. There's no guesswork there. Service levels, to me, the boiler's always been very easy to service. You can get at the areas where you need to service these boilers very easily and see exactly what you got to do when you're in front of them. Done lots of service seminars with guys, and like I say, they all basically, the reaction is that was really easy to deal with. So as far as the simplification there on the service side, we've also added in different safety functions as well with a touch of a button. So things like fixed high limit tests are no guesswork anymore. It's just essentially you go to a specific area and you push a button and you're going to get that, the test for those different things that you need to do out there in the field for your inspectors, et cetera. So lots of changes there. And big changes on the seasonal efficiency. We've increased the turn down ratio significantly on these products. We reduced the emissions. There's been lots of work on that side of it, which is kind of detailed in the overview that we went through last week. If you took that in, you would have looked at the Lambda Pro Plus on the burner of these boilers, and the turn down ratios, the NOx emissions, all those things have changed substantially. So it's a very benefit there as far as both the burner itself, as well as the ability of the end users to kind of interface with their boiler to try to increase their comfort and basically reduce the consumption of fuel to maximize that comfort and efficiency. So as far as looking at the boiler, so this is the first picture I think we see of the actual boiler in a little exploded diagram here. The heat exchanger's gone through a lot of changes. It's all stainless steel heat exchanger there now. There's been added components on the combustion side. We'll be dealing more with that, I say, in the near future. But just so you know, that heat exchanger and burner essentially is the same on the 100 and the 200. That's for the reduction of those spares that we were talking about. Flying over to the bottom right-hand corner there, we look at the control we just looked at a little bit earlier. So this is a 3.5-inch touchscreen, a little bit different than the 200 control. The touch button, I should say, not touch screen, segmented control, but very easy, again, to navigate. We're going to play around with that a little bit and some of the information we show here, but more along the lines of the startup and the commissioning. We'll look at that along with the digital tools just above it there. Again, reduction of the spare parts. The hydraulics have changed on these boilers as well. We've added larger boilers, so there's a couple of different blocks that we have to deal with here, but they're uniform across the 100s and the 200s as well, with the exception of the combi. There's no combi in the 200 series, it's all 100. But as far as the hydraulics here, you'll see those in the 100 and the 200 platforms, and they're identical. A little bit of a change there we'll look at as far as the pumps and diverting valves and stuff as we move forward here. And although it adds no actual efficiency, it doesn't, increase the, outdoor reset capability of the boiler, but it sure makes a really nice boiler hang on the wall. We changed the casing on these boilers. So the cabinet designs changed a bit. What I really like is the fact that I can pull that door off and that control off of the front of the boiler, and I've got a whole area there in front to work with as far as, you know, getting access to whatever parts needed inside the boiler. Lots of area to work with, I find, inside of these new units. The door itself as well, a little smaller door. It squares up nicely when you take it off and put it back on again, so it really makes a nice clean finish. And the finish is a different Vito Pearl white, so it's not glossy. If you pay attention to the automobile industry, you like those, you know, that more of a flat type of color, so not quite as glossy, and that's a little texture to it as well. So it just makes a nice unit sitting down there on the wall of your mechanical room. So some changes there. And about those efficiencies, this is where it kind of plays into more turn down, so higher turn down ratios, about 10-1 on all these boilers as we look through the product lines. The B1HE being the tank heating boiler or space heating only boiler, and of course the K for the B1KE is for the combi. So we're going to do some domestic hot water production with those ones as well, and without a tank. You can see a bit of a difference when we go from natural gas to propane. On the propane side, the turn down isn't quite as high as the natural gas, but pretty close. Not a big difference there on that side of it, but there is a bit of a difference there I thought I would point out. That basically, the higher turn down allows us to cover more of the shoulder seasons without a lot of cycling of the boiler itself. And the combustion manager as well, added on to the Lambda Pro, et cetera, really dials in the efficiency of the boiler as we operate. So with that Lambda Pro, looking at these numbers and turn down on that burner also compensates for things like vent lengths, issues with altitude, as well as wind. So the boiler is continuously changing characteristics based on real time. So we have no clue what's going on inside the boiler, but that boiler is doing all this work sitting there to make sure that we dial that unit into what the input we require. That's going to be safe without a lot of volatility. So it's a very safe combustion product as well as it moves through those turn downs. As far as capacities, if you went through the overview, this has all been kind of covered pretty heavily there. 30 PSI relief valves across all these boilers with the ability of increasing those up to 45 on the smaller, going to the two larger sizes, you're up to 60 PSI. The flow rates, so your max flow rates are shown there. We're gonna have a look at the minimum flow rates as we move through the applications, but we've never had an 85 in a 100 before, so 4.8 gallons per minute on that. 6.2 is the same as the current model, and then 9.3, 10.6 on the units. Those are new boilers as well, the 150 and 199, 100. So those flow rates are different for 100s we've ever seen before. Supply temperatures, we have 180 degrees is our limit for space heating. On domestic, we've increased that to 194. And an important change as well to help assist with that, that 194 is also the fixed high limit. You see it's still 210, but we've gone away with the mechanical limit on these boilers, and now it's electronic. So very similar to the 200 series larger boilers that we currently have, where you have two sensors instead of a sensor and a mechanical limit. And both those sensors basically travel together, monitoring temperature as the boiler is operating. So it keeps that boiler in a much more reliable operation and a known quantity there as far as the temperature. So when you're getting real close to your limit there at 194 F with a boiler that's got a gallon of water in it, you want to have some good temperature sensing to make sure that we're not getting any nuisance lockouts there. So we've changed all that, and that allows us to increase some of these temperatures up to those higher limits. This slide here is more to do with the, obviously some sound rating on the top there, and the NOx, the second one there. I just bought a new refrigerator, and I stand in front of that fridge and I stand in front of our new boilers. There's not much of a difference between the two of them. So that unit, sits in our kitchen, and we don't really pay much attention to it. Same thing with the boiler, pretty quiet as far as operation with the jacket on there. Obviously the cover on the boiler, very quiet in its operation. NOx is cut in about half, I think, from the previous models, and those NOx emissions are basically cover, the strictest legislation right now in North America for NOx emissions, and that's going to be on the horizon. You're going to be looking at those different types of numbers quite with a lot more regard in the near future as we start looking at things like climate change and stuff being, being more of an issue in our daily lives here. As we just went through a 50° C week in Vancouver here. Flow rates for the combi boilers, you can see we're gonna have a look at that a little bit more as we go through the application. So just keep those numbers in mind. The 150 PSI relief valve for the combi boilers, that's gonna come in the package. And of course, the supply temperatures for the space heating boilers that are gonna be doing domestic, so your B1HEs, you have the option of using an aquastat or a sensor. We're gonna see the sensor comes with the boilers when it's a tank heating boiler, but you also have the ability of using an aquastat if you wish. That's fairly much similar to what we have currently. And those flow rates haven't really changed, about 0.5 gallons per minute to start the combi boiler. Dimensions, a little bit bigger boiler. I find, but a lot more, as I mentioned, inside of that unit, you have a lot of area to work with. So it's nice and kind of spacious inside that cabinet for that. And the weights are a little bit heavier on these boilers. Obviously, the combi boiler a bit heavier than the tank heating boilers because of the little braze plate heat exchanger that's inside of those units. But you can see the weights there. What we have inside of the box, so you don't just get a boiler with Viessmann, you get a bunch of little attachments, little accompaniments with the unit as well. You can see those there. Some of them are going to be strictly tank heating. Some of them will be for the combi. So the sensor comes with the B1HE, not with the B1KE. The safety valve, 150 PSI relief valve, comes with the B1KE boiler. The rest of it comes with each unit, so universal. As we look at the closure caps there, you'll notice are, if you're in some applications, you may not have domestic hot water at all. These are caps to basically close that off, or you might be doing your application a bit differently with your domestic. You're not going to use those domestic hot water tappings on the boiler. So those little caps come with it as well. You just hang onto those, put them in the instruction sheets, whatever you need, and they stay with the boiler. Something important to mention here as we move through, we just talked about the digital tools a little bit there, just a little real brief kind of tangent on those. But when it comes to the boiler itself, so this is kind of, we got the boiler on site here, unpacking it. What we're looking for is this little cardboard box here. This is the 100 control. This is the little HMI unit and telemetry unit also inside of this little box. We flip that over. On there, you'll see that there's a little QR code. So this little QR code will link you to the hotspot of the boiler. There's also 3 stickers that come with it on the back side. So I'll kind of highlight that a little bit. These stickers are meant to basically to be taken out of here and stuck onto different areas that are going to be very visible so that we can take a screenshot of those little QR codes.
Just so one thing to point out here, Scott.
Sure, Mark.
That the QR, there are a couple of different QR codes on the boiler. Like there's one by the serial number on the rating plate. The one you're looking for the Wi-Fi is the one that has a little Wi-Fi symbol on it, right? So that's when you're trying to connect the boiler, you're looking for the QR code that has the Wi-Fi symbol.
This filler right here, yeah, it's got the SSID information, but yeah, that's the one there. And so we stuck one on our enclosure for the wiring panel that's inside of the boiler there. That's a little weather tight seal. You can also, there's also areas in the manuals to stick those. So if the homeowner is looking to do, get their phone hooked up to their boiler, they'll have access there in the manuals or somewhere visible inside the unit. As Mark was saying, there's a couple of different symbols. And this is the one we're talking about here for the Wi-Fi pairing. There's also a QR code on the actual documentation on the boiler itself, this little silver sticker. And that little QR code there will take you to a different area. So this is where you'd register for warranties and stuff like that. And, information, manuals and stuff like that would be also available in this little area of the unit. So there's 2 different QR codes. One takes you to one page. This one here is for your Wi-Fi connection. Just wanted to mention that quickly. Moving on to clearances, really nothing's changed on this from the previous model. So if your installed boilers and weren't called by the inspector as far as an issue there, you probably did it right. But basically, the one thing to mention is on the vent, we are a 0 clearance. We've passed a 0 clearance test. So sometimes your vent manufacturers might have a requirement on their venting that they have to be so many inches from combustibles. We passed a test that supersedes that. So basically, we're 0 clearance right across the board. And these are service clearances you're looking at there. So remember, 6 inches off on the left-hand side, that's where that sticker is, where the QR code lives, where you want to take a picture to basically register the boiler for warranties, etc. Your relief valve is probably going to be popped off the left-hand side here and go down to a drain, so a little clearance there as well. Inspector might want to peek their head around there and have a look at that, you know, what the model of that boiler is, serial number, whatever. So that's easy to do. They don't like taking covers off, so easier that they can see that visually. So those are some of the clearances. Like I say, not much different there. The door here has changed. This is basically going into how to get this boiler on the wall. Typically, there's going to be a little control sitting here on the top. This one, basically, if we want to get this door off, it shows a screwdriver here. You really don't need anything like a screwdriver. You're not going to turn anything. You just have to push it in to basically release the clip on either side here. So you could use like an Allen key, whatever you want to do, pop it in there. And then you're going to lift it up a little bit and slide the bottom out. And you're going to basically place that somewhere nice and handy. So now you can kind of get a grip on the boiler to mount it onto the wall. You've got the bracket here. So there's our wall bracket that comes with the boiler with a couple of anchors and stuff like that. Depending on the type of wall you're dealing with, you'll either use those anchors or not, some other application here. We're looking for wood studs. We're 16-inch on centers here. So we can basically, if your contractor is doing, you know, typical standard code building here, 16-inch centers with his wall studs, you should be able to hit a stud there pretty well. If you don't have that ability, you could put a piece, you know, put some wood across here, something with some structure. We want to put this into and anchor it to something with structure. So it's not, we know that boiler is going to sit on the wall for the life expectancy of the boiler. If it's concrete, you can use the anchors as we show here as well. But basically, we want to get this onto some structure. Once we have that leveled on the wall, of course, we can set the boiler down. Actually, we've added these little wood bits onto the bottom here, these little blocks. And if you set that, take that boiler out of out of its cardboard box, out of the skid, and you can actually set it right on the floor, and then of course get it positioned and then lift it up and hang it on the wall here. And once you're finished with that, these are basically take the wood out of here, and essentially you've got some scrap wood there for something else. You don't need it for kindling for the boiler. You just basically use that for whatever you want to do, and make some, you know, little wood animals or something out of them. But we've got those. So once we get rid of those, you've actually got these little knockouts here as well. And we're going to show this in a little bit to tie off your wiring when you connect stuff to the boiler. So kind of adds some extra benefit there, extra value to that, those little wood blocks being sitting there. We also have these little wall stands, and these are not made of wood, they're made of metal. And we would use that same wall bracket, hang that on the this new stand here. And these can be floor mounted, so you can sit these, basically anchor them to the floor, as you can see on the bottom feet here, and they can be sitting right in the middle of a room. If you want to put them up against the wall and you can anchor them to the wall, feel free to do that as well. But the whole idea there is that you have this freestanding rack now, if you don't have wall space, that you can put that boiler on and get it effectively you know, put into place where you need to. Everything is about levelness here. You can see the levels all over the place here as we're mounting the board. It doesn't matter if it's wall or rack mounted here. Level is important, and not just for aesthetics. That, you know, the guy, your homeowner, looks down and says, "This guy does a nice job because the boiler is nice and straight on the wall." It's for also the flow of condensate and stuff like that going through the boiler. The more level the boiler is, the more flush it is, the better all that stuff works. Which means that you're not going to have issues with, you know, condensate staying inside the boiler doing things that it shouldn't be doing. So the whole idea is keep it level. It looks nice, looks professional. It also helps to make sure condensate drains out the boiler effectively. These racks are now available. You see the part number on the side there. So if you need them, they're available to go. You can get those with the existing units. Boiler trim packages. There's been a change here, and we've covered this in the overviews. Basically 3/4 inch right across the board here. So your supply and return connections, whether they're domestic, on a combi or the tank heating boiler, they're all 3/4 inch. The boiler drains here that we give you, these little green boiler drains in the picture, are also 3/4 inch. Your PRV valve down here for your B1KE is a 3/4 inch, and of course, very simple 3/4 inch. So 3/4 inch right across the board, and the tappings that come with the boiler, all MPT connections. Just a note, everything cold goes on the right. So whether it's domestic cold water or your return from your indirect tank on your heating boiler, or your spacing returns are always on the right-hand side of the boiler, so we always flow in on the right. All the hot stuff comes out on the left-hand side of the unit here. So fluid out on the left. And of course, you want to add some these little symbols here are for valves, isolation valves here. Best to put those valves here so you can properly purge and fill the boilers to get the air out of them, etc. So the idea there is the field supplied components are basically in that blue that we look at, and add those isolation valves. So it makes your job a lot easier at the end to get that thing commissioned properly. Your 150 and your 199 boilers here. Difference is the supplies and from the domestic and the heating here, and the returns are 1 inch instead of 3/4 inch. All the other components are 3/4 inch that we talked about. Same idea here. You know, isolation valves so you can do proper purging of air and stuff like that through the boiler. We're back to the bottom of the boiler again here, just for a second, just to talk about the caps on those supply and return fittings on the bottom, and of course your gas connection. The idea there is that you leave those on until you're ready to actually pipe, so it keeps anything from getting inside of those piping that we don't want inside of there. We purposely on our boilers, when we installed them, we didn't use a backing wrench. You look at the inside of these, they're flanged inside of the boilers themselves there to take basically for you to thread those adapters on without using a backer wrench. So we just did it to test it, and it worked out quite effectively. But there's lots of beef on there, and a lot of guys prefer to use backer wrenches. And if you want to use a back wrench, there's lots of meat on that adapter on the top there to put a wrench on there now. Over the years, it's gotten thicker and thicker. I remember the B1HE, there was just a little sliver of, for the back wrench to get on. The new ones now, you've got a good area there to put that wrench on there. Should you want, you can add that on there and tighten those up. These little caps are basically, remember to remove them when you put your piping on there. They are fairly wide as far as the ones that came with our boiler, so it's fairly apparent you need to take them off before you thread, but sometimes caps can be plugged in there and you thread without even knowing they're inside. So just check to make sure those caps are removed before you start putting your piping together on that. Your knockouts on the bottom. So when we talk about the 200s in a couple of days, it's a big difference here between the 200s from the old and new. But this is fairly new for the 100 boilers. You've got multiple connections here for the bottom, so a lot of low voltage grommets you see there in the middle, and of course any line voltage on the outside. We'd like to keep those separate, because things like sensors and line voltage cables don't really go together very well because of the magnetic interference that you might get. We like to keep those separated, so the middle ones are the low voltage line voltage off to the side. And there's that little picture where you can see that the wiring there, you can use the block area there now, zap strap your cables there and keep the line voltage on one side, the low voltage on the other, keep those separated as well. Mentioned the on-off switch there off to the right-hand side. On these boilers, just a little review. Relief valves that come with the boiler. Nothing's really changed on this either from the current 100 to the new one. It's a relief valve off on the top. Very similar connection here. The adapter now has the added point here that we can tee in the boiler pressure gauge. So now that pressure gauge goes in here. There's no more pressure gauge off on the bottom left-hand side of the boiler. Nice looking pressure gauge as well. It comes with it. A double O-ring connection, and of course you got the clip here for keep this whole thing from creeping out of this little spot when you start adding pressure. So there's a clip there, and then we ask you to zap. There's a little zap strap comes with it, so you tie that clip off, so it makes sure that that can't inadvertently be pulled out or something like that. And of course we start losing pressure. The condensate tubing, as I mentioned, comes with the boiler as well. The whole idea there is it's 3/4 inch tubing, and we want to maintain the size of that. We don't want to drop that down to 1/2 inch here. We don't want to restrict the flow of condensate at all. The number one enemy of condensing boilers is actually condensate, ironically. So we want to get it out of the boiler so it doesn't do any, doesn't play around there and do any funny stuff with combustion, etc. So if it drains out nice and freely, you'll notice how direct that condensate pipe is. There's already a Ptrap inside the boiler. We don't need a Ptrap outside here. As direct as we can get that, and as without any basically dips or doodles in here, right straight to the condensate drain is the best. If you need to cut that hose, by all means, you might have paid for 6 feet, but you can cut 3 feet of it off without worrying. You could use the other 3 feet for something else, and get that down to a drain. And you could prime the trap as well through the boiler here if you want to drop some water down through the actual exhaust, not through the combustion air, through the exhaust, and that will get down into the P-trap. The P-trap's also has a little dirt separator in it, like a dirt trap. So it's quite big comparison to the existing one, and there's a separator in there as well for the dirt. So it takes a little longer for that thing to plug up as well. So it's pretty a robust little P-trap we've got inside of there. As I mentioned, as this mentions, it talks about a neutralizer or down to the drain. What we are dealing with here is fairly aggressive fluid. So we're down around 3.5 or so pH with gas condensate. So that water should be treated before we throw it into a floor drain. It will take a cast drain and basically cut it like a laser weld over time. It'll turn your concrete floor into aggregate. So you want to protect that from getting into things like your rivers you like to fly fish in, or your lakes you like your kids to swim in. We protect that by putting neutralization units in. So 13 years ago, when I started with Viessmann, I think 13 or 14 years ago, I would talk about a neutralization tank, and not very many people even knew what they were back then. Now we are, we know a lot more about what we're actually dumping out of condensing furnaces and condensing boilers into those drains. A lot more of our inspectors know about what's going on there too. So a lot of areas now actually have mandates to neutralize that condensate. So Viessmann we do have our own line of neutralization tanks, and they are sized for the boilers. You know, when you buy a tank from us, that's sized for that particular size BTU output of a boiler. It's all about how long that condensate spends inside of this tank before it gets that 7 to 8 out. So if it's too small, that pH coming in, and it doesn't have to spend enough time in here, it's actually going to come out. It's not going to be properly neutralized. You want to make sure you get the right tank for the size of the boiler that you're working with. Excuse me. Back to the manifolds here. So the blocks on the boilers, those high efficiency pumps are part of that now. So the 100 boiler used to have a 3-speed pumps. You set that speed. We always recommend it. Keep it in speed 3, especially if you're doing the B1KE or B1HE even, because that pump was also your domestic hot water pump. And we didn't want to basically restrict the flow. Otherwise, you wouldn't optimize the output of your domestic hot water production. These pumps are also you can change the speed as well, but they're high efficiency pumps, which means they're not just 3 speeds. There's multitudes of adjustments you can make there to basically adapt it to your particular application. This is more going to be kind of looked at in the commissioning side of the boiler, but I thought I would show you this. By defaults, we've set these for probably 80% of your applications that are already out there for these particular types of boilers. And the pump speed minimum is factory set. You can't drop it too low where we couldn't actually close the flow switch. So basically 50% is the minimum on these, and they go up to 100%. And factory settings are here for the different boilers. You can see different pump curves here as we move through, and which ones are set for the boilers that you're dealing with specifically. On that side, when we look inside that boiler where those pumps are sitting, this is what they look like internally. So when that pump is basically pushing, we're pushing into the highest pressure drop area of our system, into the heat exchanger or the boiler. As it comes through, of course, it goes through a diverting valve on the left-hand side. If we're doing space heating, that diverting valve is opened to the space heating side here. If we got a primary loop, then of course, this is kind of where that heating water is going to go in this kind of design. As soon as we switch to domestic, what happens is, if there was domestic hot water connected here, whether it's a combi or a tank heating boiler, this diverting valve is going to move and now close off this area of the boiler. So spacing is going to be blocked now. No heat's going to be able to travel to the header here at all. All that fluid now is going to go into either heating up that plate heat exchanger for domestic hot water production, or going over to a tank and heating that tank up for your domestic hot water. So 100% of priority on your domestic hot water with these boilers as a result of the diverting valve that we have in there. Inside the electronics of the control, so these devices here are all factory wired and put together, so there's really not much you have to do with these just to know that they actually exist. And these are also in the 200 boiler as well. So you've got your Wi-Fi connection here, your telemetry unit. on the side, which is basically part of the interface that we have. Your burner control unit, which does all your safeties as far as the operation of the boiler, and it's connected to the heat management unit, which drives things like set points, etc., to the unit and operate your pumps and everything else. So inside of this unit are these circuit boards, and again, they are part of the 200 product line as well. This is what we are concerned about as far as the installation side of it. So where are we going to place our connections? Where are those pumps going? Where are those sensors going to be wired to? That's part of this wiring panel. That is right in the front right-hand side of that enclosure in the boiler. And we, out of the box, you'll notice that the 40 plug is already pre-wired for you. It's got a plug on it, 3-prong plug. You plug that in the wall. You've got pump outputs. Those are something new for the 100 boiler that were never there before. And you've got basically the either a space heating pump. So you got a secondary space heating pump, which was always that relay was always going to be a third party in the previous models. Now we've got that on board here for the one heating circuit pump. And we've got domestic hot water pump. We're going to look at that in a minute. And we also have the option of a domestic hot water recirc pump. So there's 2 terminals there, but we have 3. They're programmable, which means there's 3 possible pump outputs that you can use in those 2 connections. And then on the wiring harness on the left-hand side here, you've got the 1, the 5, and the 96. So the 1, 2, 3, 4, 5, and 6 here. 1 and 2 are your basically the go to the 1 terminal. That is your outdoor air sensor. So if we're going to do outdoor reset, these boilers all come with that in the package. Desirable to do that. That's for efficiency, energy savings, greenhouse gas emission savings, all that stuff. Outdoor air reset helps us basically achieve minimizing those impacts as far as the operation of the boiler. The number 5 sensor would go to 3 and 4 terminals there. That is your domestic hot water sensor that comes with the boiler. If we're going to use an aquastat, it goes to the exact same spot. You just have to do a programming change to let it know. Look for a dry contact connection. Looks for a short versus looking for resistance off of a sensor. And then you have the 5 and 6 is your 96 plug. That is for a dry contact. So no voltage there. To go back to 96, that's your call for heat. So in our spacing system here, whether it's end switches or a zone box, we're going to look at a bunch of applications. This is where they're going to tie those connections off to. And we've got a lot of basically options there on thermostats you have out there these days. Thermostats that are basically connecting to the internet as well. A lot of those are power stealing, and they wouldn't be able to be hooked up directly to the boiler because of that power stealing area. We don't want voltage to terminate on those 5 and 6 terminals. So a nice little wiring schematic here. You can actually tie this transformer maximum of 50 VA off of the 156 connection. This 156 is fuse protected, so it's part of this. Basically, this fuse right here at the top of 6.3 amp fuse. So we max it about 50 VA so that we don't have an issue is when we start using the pump outputs here too. We don't want to overload the fuse. So keep this 40, 50 VA. And you can see going to an isolation relay. So now we've got our power stealing. So we're basically energizing the thermostat. When it has a call for heat, it closes the contact here on a relay, 24 volt switching. We close this dry contact and that enables the boiler for operation. Again, really not much different from the current model. We've never been able to put voltage on the contacts on the boiler, so it's not a big departure here from what we've had currently. This schematic is in all of our manuals. It's been in manuals since I've started with Viessmann with low mass boilers showing no primary, secondary. And the question is, can I do it? Can I operate these boilers without using closely spaced tees or a hydronic separator, whatever you want to call it, primary, secondary header, low loss header? Answer is we've got a schematic for it in the manual, so absolutely it's possible. Remembering though that there's lots of other information that we need to do here to make sure that this is going to be a successful installation. First thing is look at the flow rates. If you have calculated your flow rates are above the maximum flow rate of these boilers, and that's the boiler you got hanging on the wall, you want to put a low loss header in. Don't shoot yourself in the foot right off the bat here. That's going to require a low loss header on that 85. If we're at 5.3 gallons a minute on this system, remember we're only at 4.8 on the boiler, primary, secondary would be needed. So those types of things we're looking at. So higher than the flow rate of the boiler, we need a low loss header. We also need one if we're lower than. So if you have a system where your flow rates are dropping down below the minimums that we see here down the bottom, a little over 2 gallons a minute for the 85 120, just under 3 gallons for the 150 199, then we want to make sure that that flow switch is going to basically get hit. And we want to make sure that that pump is going to be able to push that flow switch closed. So primary, secondary would be required as well there to make sure those any zones that are smaller than this in flow rate would actually enable the boiler and release it for operation. So the other thing is that we recommend putting a pressure activated bypass here. That's what that looks like right here. I've highlighted it. And when it says, when we are trying to basically, if there's components installed in your system that may isolate the flow of the pump, this little pump on space heating is actually going to delay off, which means that once your thermostats are satisfied, boiler stops. This pump is basically still pumping around to get basically just to release residual heat out of the heat exchanger and dump it into the system here. If you have zone valves, those are the components we're talking about here, connected to this system, and they're all closed, then of course this pump is just deadheading against your closed zone valves for a couple of minutes. That's not good for a pump. That's where some sort of a bypass would be required here, basically to make sure that we don't deadhead this pump and damage it. And we're starting to replace circulators now because our pumps are failing. So a very important component here to think about when we're doing this type of application. And this really gets us into primary closely spaced T's. You're pretty close to the cost as far as labor, almost identical to a closely spaced T system, primary, secondary. There might be reasons why you don't want to use primary, secondary. I get it. But if your whole idea there is that you're just basically, I'm going to cut some costs by doing this system versus primary, secondary, you're not. You still need that pressure activated bypass. Probably cheaper to put the closely spaced T's in reality than buying a pressure activated bypass. Using this slide here as well, very important if you do decide this is the system I'm going to go with because it fits my application, it's got to fit. That expansion tank location, we are pumping away from our boiler pump in this application, pumping away, it's pumping into the highest pressure drop area of our system, pumping away from the point of no pressure change. That's the ideal location on the return of these boilers. If we are to pop that onto the supply, what would happen if all of our zones are closed here now and we switch to domestic hot water is we're going to isolate that tank out here. It's going to be sitting out here, twisting in the wind, and our pressure gauge is going to increase and we're going to pop the relief valve. Because that diverting valve, remember, closes this, basically this side of the system. It actively closes the supply pipe connection here, and the zone valves are going to close this from the return side. So now we've got basically no expansion tank connected to the boiler when we do domestic hot water production. So if you have that, again, not much different than the current boiler, but something to point out as far as your operation or as far as your installation, to keep those expansion tanks on the return side as much as possible, avoid any problems. So applications, what it comes down to with these systems here, primary, secondary, or not primary, secondary, really comes down to a little bit of math that we are going to deal with. There's our heat transfer equation, Q being our BTUs that we need, whether it's the whole load or just one of these zones that we're talking about here, is going to be a function of the flow rate multiplied by that delta T, multiplied by the constant for water, which is about 500 in our hydronic equation here. And so very simple to kind of work out what we need as far as BTUs as we move through here. So when are we going to look at this as far as primary, secondary? So let's have a peek. We've got 150,000 BTU B1HE boiler here. We got 3 zones that we've just made the math easy at 47,000 BTUs a piece, each zone. 141,000 BTUs of heat requirement here. If we do the math on this, what are we looking for here is the delta T that we can work with. So we kind of move the equation around here now. Delta T is going to be a function of the BTUs we need divided by the flow times that constant. And we see here that we're working with a 32-degree delta T on our system. And we look at basically, we start getting into, the 30 to 35 here. We're looking at on the 199, we're looking at closely spaced T or low loss headers here. On the 150, we got the same issue, or 9.4 gallons a minute. So a 32-degree delta T, we need to put the bypass in here. But what if I needed so that's safe. What if I needed 20-degree delta T? So what if I was looking at a, my design required this baseboard to basically only have a 20-degree temperature difference between supply and return? Putting that number in there now, we see our flow is at 14.1 gallons a minute. We're at 8.8 max. That's when we're going to want to start putting in low loss headers. So we're looking at what our delta T is for our system. It's got to match. If it doesn't match the boiler, then we add the closely spaced T's or low loss header in that case. How about flow rates? So we got a system here, 3 zones, 150,000 BTU boiler. We got a total of 8.5. So, hey, we're down below the maximum flow rate. So this allows us to do this. But if we look at the flow rates here, this last zone, looking at it, is below the minimum to actually engage the paddle. So if this one zone was calling, the boiler actually wouldn't start. We would basically, the pressure drop across the system here is sufficient enough to basically that our pump at the speed we have it at is not going to supply this particular loop 1 gallon a minute. It's going to basically keep that paddle closed. So when we have those types of instances, we have lots of zones like I see here, and you're not calculating flow rates. It's a pretty good chance that one of these is probably going to be low enough that we're going to require a primary secondary system here to make sure that we have sufficient flow to start the boiler whenever one of these zones here is called. So below minimum flow rate, a narrower delta T than the boiler, those the low loss header closely spaced T's really start to make sense as far as your proper operation. So what's the difference between these two? Low loss headers and closely spaced T's is what we kind of use. As far as the boiler supply, we see them both here. You got your boiler returns coming back on the low loss header on the same side. Same with the closely spaced T's here. System supply out, system supply coming out here on the top, and the return. Inside of the system here, so we have flow rates that are the same. So basically, our flow rate on the primary side and our flow rate on the system side are the same, 6 gallons a minute. What happens basically inside of these units is they just act like a straight piece of pipe. So if I have 6 gallons a minute on the low loss header side here, that 6 gallons a minute is just going to go right through the low loss header, right out to the system. And of course, basically 6 gallons a minute comes back in the return, right back into the boiler return, 6 gallons a minute. Closely spaced T, 6 gallons a minute comes at the T. It's going to move basically on the supply and return 6 gallons a minute back. You got basically a little dead space in here, a little dead space inside the low loss header whenever our flow rates are equal. So that's what it looks like. So T1 is also going to equal T2 in this case. So that means the temperature coming out of the boiler, if the flow rates are equal, will also be the same going out to your supply. Now, if we change the characteristics up a little bit, now we're in the design season, and we got 10 gallons a minute on that system, still 6 gallons a minute on the boiler side. When we start dealing with the differences here, a low loss header, the low loss part here is pressure loss. Basically, what we end up with is a laminar flow in the actual low loss header itself. And when we have this particular setup, that doesn't necessarily mean that the boiler flow has to fully go through out to the system here. There can be some basically mixing inside of the low loss header to get us that difference between the 6 and the 10 gallons a minute. On the closely spaced T side, it's all about pressure differential. So when the whole idea here is that if we have P1 equal P2, and that requires us getting about 4 pipe diameters distance on center between the T's here for proper connection of our closely spaced T's. When we're at 4 pipe diameters or less, P1 is going to equal P2. And when that happens, when water flows through here, it's not actually going to see that there is actually any branches here. It's going to go flow straight through and around. Same on the boiler side. There's no flow on the secondary side. The boiler hits there and it sees that it doesn't see these branches because the pressure difference here is going to be greater between these 2 points than between these 2 points. And that water is going to flow right back around and out. So basically the whole idea here is closely spaced T's is just that. We need to make sure those T's are as close as we can get them together. 4 pipe diameters is the best. And that's going to make sure that we have 0 pressure here between the T's, and our closely spaced T system is going to work. So when we have this set up now, what goes on inside the boiler is as the, or inside the T's here or inside the low loss header, as that water comes back, we get 10 gallons a minute coming back on the system side. We only want 6 gallons a minute come back on the return here. We can't have 6 and 10 on the boiler side here. We're going to end up with a bypass amount when it comes back. 4 gallons a minute will bypass through the low loss header and blend with the 6 gallons a minute from the boiler here, and the same with our closely spaced T's. 6 gallons a minute will basically go into the boiler return. That 4 gallons a minute is now going to bypass and blend with our boiler supply here. But that means T1 is not going to equal T2 at that point, right? We're going to blending here of a return with that mix. So there's a difference between the temperature of the boiler and our system supply when there's different flow rates between the two primary and secondary systems. The other advantages of the low loss header or primary secondary headers, et cetera, is that they're also excellent air separators. So because of the change of velocity as that water moves into it, the air will basically be separated from the fluid. And of course, in our low loss headers, we dip that down so the air can't move with the fluid out to the system. It all kind of sits up in here. You drain that off after commissioning, and then it accumulates in this little air pocket here, continuously separating air from as it flows through here. You also get a little debris trap here. You get a drain valve. You can start draining the dirt out of your system. It doesn't get back into your boiler. Those aren't part of the closely spaced T's. Those are basically, and also you add some fluid volume. So here's about a gallon of water in a little boiler, little 100. There's probably over a gallon of water in this little low loss header that we're dealing with as well. So it adds some mass, which, you know, believe it or not, those low flow rates will make a big difference in the cycling of your boiler as well. So lots of value added with a low loss header in comparison to close spaced T's, even though they do primarily the same function. This is one that you're not going to hook up to a 100 boiler. All right, so we've got the applications. We talked about the expansion tank a little bit there. So where we want to put those expansion tanks with a primary, secondary system. We have an air separator over here with a closely spaced T system, and we've got the expansion tank basically teed off the bottom of the air separator, or on the return if you put on the primary, and of course you've got that on the return side, your air separator on the boiler supply side. This is the hottest, basically where the hottest water will be, so that's where the air separator is going to be the most effective. But air separators are multi-pass devices, so it's not like you have to catch 100% of it at the first shot. It's all about basically, you know, gradually ensuring that the air is getting eliminated out of these systems over time. So in our applications here now, let's have a look at it. We're almost, looks like we're about an hour in, Mark.
Yes, sir. I was just going to tell you that.
All right. Right. I'm on it, dude. Yeah, coffee's kicking in here now.
You're just way ahead of me now.
So we're in the applications. We're gonna have a look at this, going through the different ways we can wire these boilers and connect them for our different, you know, systems that we have out there. So this is a pretty straightforward baseboard system. It could be a, you know, it could be a bunch of radiants, you know, radiant inflow systems as well. It doesn't really make a difference. Basically, it's 3 zones of heating that we have on this particular boiler. We take the 40 plug, we plug it in the wall, make sure it's polarity correct. This will come up in the service side of the boiler, but basically we are using flame rectification, which means the path of power has to go through the boiler the correct way. If it doesn't, you're going to have lockouts on ignition. So always good, especially if you didn't wire this plug, just to make sure that when you plug it in, check for line to ground, make sure you got 120 here, or 120 line to ground, not 120 neutral to ground. That would basically be a reverse polarity. We'd have to make that, we'd have to correct that before we would start the boiler up. We got our thermostats here. And of course, the thermostat, nothing really different here. We're going to wire the thermostats to a transformer. That transformer could come out of the 156 connection. Remember, if it's below 50 VA and a three zones, you should be working with a 40 VA pretty effectively anyway. Line voltage off of the 24 volt, right, connects to your thermostats. Nothing different there than what we do on a daily basis when we install zone valves. And then of course, the zone valve end switches, they'll go back to the 96 right here. Didn't want to kind of muck up the schematic here too much. So right back to the connection here. Our heating system pump off of P2. So our heating system pump sitting right here comes off of that. And of course, our outdoor sensor is connected to the number 1 terminal here, 1 and 2, to get our indoor temperature feedback. Now, as far as outdoor temperature goes, kind of moving into that, we have the option with either constant flow or outdoor reset. So you don't have to use the outdoor sensor. It can stay in the box, you know, on top of the water heater, whatever it is. But as far as value added, that is the biggest device for energy savings that we actually supply with the boiler that you can use as an option. And just think about this for a minute. Kind of consider the fact that when we are designing a heating system, we design it for the coldest day of the year, minus 20 C, wherever this might be. It's a nice cold, windy, wintry day
That's where I
there.
am. That's where I
That's where
am.
Mark's sitting. He's hiding behind those trees somewhere.
Oh, I'm
So
inside.
that's the window. He's looking out. There it
That's
is.
right.
Yeah. So there's the location. There's the 100%. We need 100% of that boiler capacity at that temperature to make sure the occupants are going to maintain, comfort level of 20 C in their 3 zones. And what we're doing there basically is we are right now with an on-off control. Anytime one of these zones calls, that boiler is going to fire to that temperature right there, 75 C, 167 Fahrenheit. When it's plus 10 outside, we're still going to send that the zones, these baseboards, this exact same temperature. So we needed that 75 degree C water to make sure that we can maintain 20 C at these thermostats. But now that's plus 10 instead of minus 20 outside, the temperature going out here will probably overshoot, basically short cycle the zone valves here. They're going to hit that, and it's going to heat up much quicker than it was at minus 20, and you're basically going to have a much quicker cycle rate on your zone valves here at that exact same temperature. Not only that is the fact that we're talking about condensing boilers here. So the whole idea with a condensing boiler is to get that temperature into condensing mode as quickly as possible. Typically speaking, with high temperature systems like this, you're not going to achieve a lot of condensing, if any, with these high temperatures that we're looking at here. So that basically that's that fixed set point advantage there. Basically is simple as far as its operation. You're not wiring the outdoor sensor, but you're really leaving a lot on the table here as far as the energy savings goes. So effectively, this is what you've done. You've decided that it's minus 20 degrees C every day where this boiler is. So happy Groundhog Day boiler. So if you remember the movie Groundhog Day with our Canadian treasurer Bill Murray in there as the reporter, every day he wakes up, it's Groundhog Day. The same idea here with your boiler is every day is Groundhog Day. Every day is I'm going to hit 75 C when I get a call for heat. It's very similar basically to wearing Mark's wearing his snowsuit here at minus 20, and his mom puts that same snowsuit on him when it's plus 20 outside. Very different. You're going to be a lot more comfortable at minus 20 with that outfit on than you were going to be at plus 20. But the same concept here is with your boiler and with your building actually is the fact that that building is not losing the heat at the same rate at the warmer temperature that is at that design temperature. So it only makes sense at that point when it's minus 20. Yeah, we're going to hit that 75 degrees C. We want to make sure that the people in that building are as comfortable as possible. But if we use the outdoor reset control now, that outdoor sensor, and we have a condensing boiler, we've got the whole range here we can play with. It's basically, it's if you want it, it's right there. Go grab it. And at plus 10 now, if we use the outdoor reset control, and with this particular heating curve, I remember there's multiple heating curves. There's just one of a bunch that we're working with here with the baseboard. Now we're at about 40 degrees C temperature, but 104 degree Fahrenheit. So there must be a lot of baseboard in this system to be able to operate at that low temperature. But the concept here is now that boiler is actually condensing, right? So now you're gone from about 86% efficiency on that board to somewhere closer to about 93% efficiency on the unit, 92% as it's operating. And it's also not going to basically cycle your zones here. So the cycle rate of the zone valves and the thermostats will be similar at plus 10 as it was at minus 20. So that's really what you'll want is that same kind of impact on the heating of the building at the same rate, whether it's plus 10 or minus 20 outside as we see here. So we're still going to have the occupants happy at, they're going to still have their thermostat set at 20. They're going to achieve that. What they don't know, though, is that the temperature is dropped by about 35 degrees C to still supply in that particular temperature. So you're going to save them a just a bunch of money using that outdoor sensor that we're looking for. And like I say, the whole idea there is, coupling the boiler operation with the outdoor air temperature. And what that does for us basically is we've got the heating curve here. Now a 100 heating curve, I should mention, does not have this part to it. It's basically, you've got your outdoor temperature and of course your supply temperature, and there's a slope and there's a shift aspect, but there's not a room temperature set point aspect. That's a 200 heating curve. But basically what we're doing here is comfort level is not being sacrificed, and that's the most important thing to the end user, is that they're comfortable. They don't have to put a sweater on if they don't want to. They can leave their system as comfortable as they want. They don't have to basically, open windows basically to be comfortable in the, in the winter, because we're overshooting temperature. The heating curve basically allows us to basically operate that system with a thermostat, not using the window as a thermostat as well. We save energy as far as fuel. That's the part that we're trying to achieve with the outdoor reset, is that fuel energy savings. And of course, the cooler the temperature, the more efficiency as far as losses go. So we lose less heat to the ambient air around the boiler, and less wear and tear on the equipment, less cycling going on, less parts replacements. All those things are all to the advantage of both the end user and the boiler itself as far as its operation. Now, getting into some more, I just want to kind of touch on that outdoor reset and why we'd want to use it versus that constant temperature. Now, both are there. Which one is more desirable comes up to your system. We've got a radiant inflow system here. We changed it up a bit. Instead of these radiant inflow panels, now your in-switch contacts are going down to a zone panel. And we've got multiple pump outputs here. So we only have one pump output on the 100 boiler, which means we need to use some sort of a zone control like this. When these end switches close, they turn on the individual pumps associated with these particular radiant systems. So there might be one large zone of radiant, or it might be actually 6 zones of radiant here. It might be 6 here, it might be 6 there. Depends on how they've laid these pipes out. The 120 volt into the control, obviously, we don't make these panels here, so we're just basically saying, wire them as per the manufacturer's instructions. The outdoor sensor is in the same spot. And of course, this is the important part. This 96 connection is a dry contact that comes off of these zone controls, and they terminate on the call for heat. So anything here calls, it still hits this dry contact, and we start that boiler up for space heating. Getting into a domestic hot water application. So the ones we looked at where it had no domestic. Same concept here as far as wiring the zone valves we just looked at. Nothing's different from the first application drawing we looked at. Our temperature, our thermostats, wiring to our zone valves, and then our connections to the control here. This is a combi boiler though, so we got our combi out on this side. And again, if you've got, instead of the thermostats that we have here, if they're power stealing and you're wiring them directly to the trying to wire those directly to the panel here, you would need a series of basically the same kind of idea here. We would have a contact and relays. So simpler. You a lot of times just use some sort of zone panel to get that central, but a nice little package here if you just have like a couple of zones to work with. The B1KE with a spacing temperature, and now we got the zone box. So we've got the zone valves connected to the thermostats as we show here. Our 96 connection down to basically off the isolated in switch connection off of the zone panel down to our 96 outdoor sensors where it was before. But now we're dealing with, that domestic hot water. So what are we dealing with as far as domestic on the B1KEs? We're talking about this. How many, fixtures are we usually working with? We always recommend with combi boilers that you can have multiple devices connected to it, but oftentimes it's better just to use one device at a time, because there's things like sandwiching of the temperatures, et cetera, that you deal with on combi boilers sometimes, where you shut the water off or open the tap up, where there's a shot of hot or a shot of cold water that might occur there for a short period of time. But there is the ability, obviously, if you got multiple bathrooms, like how many of these can be operated without overshooting the flow rate of the boilers as far as their capacity for domestic hot water. When do I need to go from a 120 to a 199, for instance? Those types of questions. We looked at the information here briefly in the specs engineering data that we played around with for a few seconds previously. 3.3 gallons continuously on the 120 at 77-degree rise, or 4.7 on the 199. So if we want to know what we're dealing with as far as water and showering and all that kind of stuff, we need to know a few bits of information here. So we can simply, with a little bit of math, we can figure out, if we're targeting 127-degree Fahrenheit water as far as our set point for domestic hot water out of our boiler here on the combi, we know that's 127 coming out of the boiler. We can't tell, 100% what's going to actually hit the fixture. There's dampening going on with your piping and stuff like that. But just kind of assuming that we're going to take that out of the equation, the dampening of the hot water connection going through the building, just coming out of the boiler itself here at 127. If we know that temperature there, we also know what the cold water temperature coming into the system is at 50 Fahrenheit. We got our 127 coming out of our boiler. We need to know what our desired showering temperature is here, and we need to know what the flow rate of that fixture. So the information here, there's a couple other bits of information as well you probably need to deal with, but right out of the box, trying to figure out this little conundrum, we need to have a bit of information here to figure out what percentage of this water hitting this shower is actually the boiler heated water at 127 Fahrenheit. So this little equation, shower temperature 103 subtracted by 50 Fahrenheit, our water coming in. 127 is our boiler heated water supply, and minus the cold water coming in. So basically what we deal with here is a percentage. So about 69% of the water flow out of this fixture is 127. The other percentage is the cold water, 50 blending with it. It gets down to that 103. So 1.38 gallons of water is at 127-degree Fahrenheit hitting this particular fixture. So we have 1.38 demand with this shower going. If we were to look at other showers going here, so if we had 3 showers simultaneously occurring, we'd have about 4.14 gallons of water coming out of these fixtures at 127 degrees. And with our B1KE, we wouldn't make it. So we would be a little short. But at 2 showers, we'd still have a bit of reserve capacity, about a half a gallon or whatever of flow. On the 199, at those 3 showers, we're at the same capacity there. So we're at 4.7. So we're at a little bit more reserve capacity there as well for maybe washing some dishes or whatever. So there is some pretty powerful capabilities of these units. Again, is this something that you'd want to do? Possibly, but you have to remember, as the more people using these, this guy turns that shower off. This guy and these guys are going to get a little bit of hot water as this boiler basically adjusts its modulation for that particular reduced load. So some things you have to consider when you're dealing with combi boilers that you wouldn't with a tank heating boiler. So a little bit of information there. Again, those that gives you some concept of what it is. There's a lot of variables in domestic hot water production with combis, specifically the piping losses that we can't account for. So just out of the idea there, that's what you're kind of working with as far as the capacity. Some other things that have been added to this boiler, we had an eco and comfort function in the 100 boilers, right from the Combi Plus to the B1HE or B1KE boiler that we currently sell. That we've changed that and kind of, I think, lifted it up a little bit into a kind of a more practical application. It's actually part of a time program now on the Combi boiler. We can program in up to 4 on-off periods per day, but we can actually program in a comfort schedule, which means during those comfort times, the boiler heats that domestic hot water heat exchanger and maintains it between 2 and 10 degrees C from the set point, your desired set point for domestic, so that when you turn that fixture, that hot water on, there is no delay in the boiler firing and to get that hot water out to you. It's instant, literally coming out. So as soon as you turn the tap on, that water coming out of the boiler is hot. Depending on how far you are away from the boiler, that's the delay between, you getting cold water and hot water delivered to that fixture. So just an added feature there. If we move on to the B1HE, so instead of the KE boiler, the tank heating boiler, you see a little schematic here of how those are piped. Your closely, your connections here, your domestic on the inside, your spacing on the outside, to a low loss header. Nothing here on the heating side really changes as far as our connections, right? We've got our zone valve and switch connections on the 96, our outdoor reset, stuff that we've already looked at there. So let's kind of move through here. But what is a little bit different, we talk about the B1HE, is what is controlling that tank temperature now. You have the option of the sensor that comes with the boiler or the heating aquastat. Which one you're going to use may depend on, you know, the tank that you're using. Maybe it requires you to use the aquastat versus the sensor. Maybe you want to supply a little hotter water than 140 that you have, and that's a possibility too. Although there's a function now that we can release that as well. As far as a domestic hot water temperature, typically you're limited to 140 Fahrenheit with the sensor, where the aquastat, you're dictated by how high you turn the aquastat up. Keeping in mind that you're within range of what the boiler can give you as far as domestic hot water, and also make sure you're putting some anti-scald or some sort of mixing, a tempering device on there when you're getting those temperatures up into those high areas, because you can risk scalding quite significantly at that point. But both of those connections are on the number 5 terminal, as I mentioned earlier. You just have to do a little change of programming in the on the aquastat here for that same function. And now that we got a tank, we got a recirc pump, and now we can wire the recirc pump off of the domestic hot, the domestic hot water recirc pump off of the P1 contact here, and program it for that recirc application. So currently, the heating pump is off P2, recirc pump off of P1. The tank heating pump is inside the boiler, which is also the boiler primary pump at this particular application. We get into multiple temperatures. Really, this is where we start dealing with where a 200 would really come into the forefront as far as the star. We can deal with multiple temperatures very easily on a 200 boiler. With a 100, you've got the one pump output. It's a one temperature boiler. You're going to hit one contact TT. So when you have multiple temperatures, you have to deal with that basically with third party, which means things like tempering valves, mixing valves on the lower temperature circuits to make sure we don't overshoot temperature going out to those. And I just mentioned a couple dates here for you to have a look at if you're interested in the 200 application or startup and commissioning there. So let's have a look at how this all works. Basically, when you start dealing with multiple pumps on the secondary, you're going to be dealing with different relay boxes or pump relays, whatever zone panels, whatever you've got out there, different manufacturers. And you want to have a look at something a little bit different when you're dealing with this type of application possibly. But on the domestic hot water side of it, everything's still controlled off of the boiler. So don't worry so much about that. You've got your zone panel here. So we got one contact for the low temp, one contact for high temp, and of course our 2 pump outputs here. We're still using that dry contact over to the boiler, and that's our call for heat on the 96. So basically you can see here, we're going to design this system to supply the baseboard zone with its heat. And of course, we're going to temper down to the radiant side of it. So the boiler only knows that there is the baseboard system out there that it's feeding. And you are basically in control of the temperature going out to the radiant panel at that particular point. So we get into other temperatures here. There's the combi boiler. Same kind of idea. It just basically the spacing side, whether it's combi or heating boiler, there really is no difference. We have the same connections here. With a fan coil, you might have a board in the fan coil here. Sometimes they have their own individual pumps inside the fan coils. I know our Airflow Plus has its own pump. We don't have a pump out here. It's inside the boiler. But in this application, just use a generic air handler. You've got your contacts for your space heating. You have a dry contact on that will go down to your zone panel here. And now we have one common call for heat here, regardless of which one is calling. And we're going to design the system again for that high temperature circuit. So the air handler will be the one that's going to control the boiler temperature. And we're going to throttle down on the this one here. I actually should have put a mixing valve in here, tempering valve in there. So next week you'll see a tempering valve in this little area there. I'm half asleep and I still notice that. So the Other application for these boilers, and like I say, this is kind of a nice one in retrofits I think about specifically. So when a guy has like a WB1A or a WB1B boiler 100 and he wants to replace it with a new B1HE unit, but all of the piping is for the WB1B boiler, right? There's not the 4 tappings, there's only 2 on those older units. You can cap off the domestic connection, and now you can move that a tank over to the secondary. In this application, there might be already have a wiring panel on the wall there as a retrofit. So it's already pre-wired, everything right down to the tank connection, everything else. All you're going to do is basically move those wires to the right terminals on the boiler here. And now you'll see what happened. We program this where when the boiler calls for domestic hot water here, we still have priority over the space heating pump in this application. The recirc pump here is still available because we're going to take the domestic hot water pump off of our zone panel here. And of course, what we're going to do is flip this with priority. So basically, when the domestic pump calls, the spacing pump is going to shut off. And of course, when the domestic is satisfied, the spacing pump, if there's still a call for heat, will come back on again and supply that temperature. Unique is right here, up in here. You got to make sure that if you're dealing with a retrofit or if you're going new here, that those contacts, there's 2 contacts here. One that is for the space heating call and one that's called a priority contact, so that when the domestic calls here, that it actually closes this contact and tells the boiler it's a call for domestic, not just one call for space heating. So important that that box has 2 isolation contacts, one connected directly to that priority zone in this particular panel. And also aquastat, not domestic sensor, is going to go to the panel. It's not going to read a sensor. So we need to have something that's going to close a dry contact here. You can also wire this directly if it's a new installation, directly off of our system like here. The only thing that's different in this application is we lose the domestic hot water recirc pump because we have to program our tank loading pump for our domestic here, and of course our secondary spacing pump over here. Still priority over these 2. When P1 calls, P2 is isolated. And if you want a recirc pump here, you'll buy a one with a timer on it, or some other operating off temperature, whatever it might be. But we won't be able to control the domestic hot water recirc pump when we have these 2 pumps wired back to our wiring panel here. And just be aware that when you do pipe that tank on the secondary, there is elevated temperatures. So that might not be a problem so much with baseboard systems. But once we satisfy the domestic load here and we have a radiant system here, we're also going to have, that hot heated water is already in the secondary side of the boiler here, and you're going to get a shot of hot water going out to those low temperature circuits there. So there might be something you might have to consider when you do this type of piping to make sure we don't overshoot temperature on a radiant panel. That will be for a short period of time, but it's still something to be considered there. Some other features on the B1HE that are new or a bit different than previous generations. The first one we just talked about, that primary secondary connection for the domestic hot water is now capable. You couldn't do that with the B1HE boiler. We have a time program now on the 100 boilers, so basically we can do setbacks, on-off tank heating schedule. We'll cover that in the commissioning. There's a sensor. If you use a sensor, you have that. If you use an aquastat, you don't. The one-off domestic hot water heating outside the time program. What that is basically is the ability of just going down. If you're normally not going to be heating domestic, but for some reason you need some hot water, you can go down and actually not take it out of the schedule, but just basically go in and override the schedule for one event to heat the tank up, provided you have the sensor. There's a hygiene function basically now. So that's what we called it in years back called anti-legionnaires function. So basically what will happen is, one time period a week, you can jazz this tank up to a high temperature and kill the bacteria in it. And basically to make sure that we keep, any issues with bacteria at a minimum, mitigate that. And there's also a scald protection function, which means that there's an override that you turn off if you want to have that temperature higher than 140 degrees with a sensor. Again, very important that it's scald protection here. So you want to make sure that you have some sort of device on there to make sure we don't overshoot that temperature and harm somebody that's, washing their hands or something. So some added functions there. This one I didn't have enough space to add in that one little slide, but there's also an override capability as well for the domestic hot water now, which basically says there's a time limit for me to heat the domestic. So if I exceed that time limit, what's going to happen is it's going to shut the domestic off. It's going to go back to space heating. And there's also an address that you would use to basically, this is the time frame that we're going to delay until we basically go back to trying to heat that domestic hot water up again. So there's kind of an override here at domestic hot water priority with a time limit to retry that domestic as part of that package as well. And that's strictly on the HE boilers. That has nothing to do with the combi units whatsoever. So that was it for some of the application stuff and the piping and the wiring schematics. I hope that some of that stuff was fairly interesting. Pretty straightforward on that. There's not a lot of magic going on there. The 200 boiler is going to be a lot more of applications to kind of work through. So if you're interested in that, there's going to be a bigger portion of that in the next presentation. As far as the gas connections, this is basically on the install side, just remembering, you want to make sure you're at between 4 to 14 inches, and that's on static. So usually you want to be a little higher there for pressure drops when that valve opens and for high fire production to make sure that you've got enough gas pressure there. So check your gas pressure. If it's over 14 inches, we got to get that down before we start the boiler up. And on propane, we basically have a lot less wiggle room. So your 14 inches are max, but we can't drop down below 10 inches on high fire. So just something to be aware of when you're dealing with the gas delivery side of the boiler to make sure that we've got enough pressure there and we're not over pressure to be a problem there. That helps out our Lambda device. This is the gas piping. I hear somebody. Does somebody want to say something?
I was just going to say you got about half an hour.
Okay, so on the gas piping here, this is the picture in the manual. You see no appliance reg in this particular application. If there is an appliance reg in your system, you want to look at the manufacturer's instructions and best practices. Basically, the requirement, a lot of them we'll look at here, would be to have that about 8 to 10 pipe diameters of straight pipe on the downstream side, the low pressure side of that reg, and about 3 to 5 pipe diameters upstream or the high pressure side. And that's just going to basically allow for things like, make sure there's no high lockup pressure. So the next time the boiler fires, it's overfiring because there's not enough downstream pipe here to basically kind of minimize the pressure on that regulator. So high lockup pressures are mitigated with a little bit more of a pipe run here. And you're going to deal with a lot less ignition problems with the boiler. So why not add a few extra inches of pipe here and there on straight runs to make sure we got a good connection to the boiler. On the venting side, we're just about finished here. And I just want to mention the boilers, because of that whole product line kind of, universal throughout, the adapter is 3-inch on the top of the boiler, even on the even on the 85. It's the same one as we have on the 199. It's that whole concept of reduced spares. And there is the ability of venting these things on 2-inch. It's not that we go with 3-inch venting, but just to kind of mention, you've got 3-inch in the exhaust off of the adapter on the boiler. You got your combustion on the outside here for coaxial venting. If I'm doing 2-pipe, I leave the cover on the top here, and I take a knockout on the left or right hand side of the boiler for our 2-pipe system. If I'm going coaxial on these units, basically nothing has really changed. We use the same manufacturer, Viessmann, Cox-Gillen venting, but there's other manufacturers that do have coaxial venting. Our part numbers and stuff like that haven't changed either. Same kind of thing, vertical or horizontal. There's our vent lengths, and I only put these 2-inch vent lengths in here. Actually, I think, is the testing this week, Mark, or is it all finished or wrapped up as far as the final?
The venting, all the testing has been done. We're waiting for the feedback approval from the regulator.
Putting you on the spot a bit there.
Yeah, no, it's fine. All of our testing has been done, all of our to make sure that it works. But we have to wait for people like CSA and stuff to sign off on that to get the approvals. Mm-hmm. So that's just what we're waiting for right now. CSA, because everybody's in a backlog and everybody's working shorthanded because of COVID, it takes a little bit longer.
Okay, yeah. So just a little bit, like I say, a little bit of that, but those information. So take these as gospel as far as the 2-inch side of the boiler. Some of the 3-inch and the 4-inch stuff I think is actually a little bit bigger than it was before as far as longer vent runs. But as far as the 2-inch there, these are placeholders I think right now. I just want to put that in there so that you know it can be vented 2-inch. The final length hasn't quite been released to us or revealed to us. But again, nothing's really changed here as far as what we're looking for. I'm not going to go through all this stuff just for time, but basically we're still doing our vent counts, right? So you look at the straight lengths, you got basically equivalent lengths for the elbows here that we're dealing with. Remembering that the first elbow on our boilers, basically you don't count that in any of the vent calculations. So it's just basically that first one is free, even though you pay for it, the calculation is free. And the rest we count up. As long as we stay within the vent table, then you can go ahead and vent that boiler that particular method. We'll move through here on the vertical, same kind of idea, make sure you're in code with what you're doing, whatever you're doing there as far as your distance from the peak of roofs, etc. Those are all code requirements. There's nothing to do with Viessmann. We're just supplying you with the components here. It's up to you to make sure that you're within the codes when we do this. Some clearances here as far as vertical vents and terminations and stuff like that we need to be away from multiple configurations. But again, we're staying within the vent tables, and this is what we're kind of looking at. 2-pipe systems, you have basically 3 configurations of 2-pipe with the added hybrid system here, vertical exhaust and a horizontal combustion air. We don't do a vertical horizontal combustion air and a horizontal exhaust. The reason being is that when you turn the boiler off, this little pipe is going to create draft. Just because the difference between the pressure here and the pressure up here, we're going to get some draft going on. And of course, that's going to pull any residual flue gas back into the boiler, and you're going to get combustion air contamination. And that's going to basically hit devices that aren't made to basically have that acidic flue gas hit across them, and you're going to have problems. So we don't allow this particular hybrid type of system. We're always going vertical on the exhaust and horizontal on the combustion air for our 2-pipe systems. The piping hasn't changed. So basically everything here is just in a little bit more detail. There's a separate presentation for venting. That's why there's so much information on here. But the same kind of concept with 2-pipe systems, remembering that you have A plus B. So with combined lengths, we're adding both the combustion air and the exhaust together here to come up with your equivalent lengths. And of course, making sure the elbows and stuff are all accounted for in their equivalent lengths here. So the whole concept is to make sure that we're within those terminations, right? Or within those vent termination lengths that we're dealing with. The big difference here is the different types of products, right? Stainless steel venting, the elbow counts are different, right? So your equivalent length's a bit different between stainless steel and PPS. CPVC and PPS are pretty much the same, but the elbow counts here, right? They can make a big difference in your overall equivalent length, depending on what you choose to use there for materials. And the last one here on rigid is going to be single venting, or what we used to call room air dependent. I don't know if we still call it that or not. And basically, you've got to calculate here via B149 code in Canada, at least, what that combustion air duct has to look like. How big does it have to be, depending on the size of the boiler and other gas burning appliances in that mechanical room. Make sure that's big enough so that when that boiler fires, you're not starving it of air, right? So you're responsible now for the combustion air passively going into the mechanical room to feed that boiler what it's looking for. So the same vent materials are approved here. Same essential vent lengths as we were looking at before, but now it's all on the exhaust pipe versus the combustion air and exhaust. Our vent counts are there. So same idea, very simply, you're just adding the lengths together here and making sure we're within the elbow counts that we're dealing with and the straight length counts that we're dealing with on the tables themselves. Right, there's a 4 o'clock in the afternoon on Friday call of no heat right there. Flexible vent pipe system. Again, nothing has changed on this as far as application. The idea here is that the flexible vent always goes basically vertical. There's no horizontal component to it. You don't want that to sag when you start heating it up. But your vent lengths have dropped a little bit when you deal with flexible versus rigid. So about 25% loss of the equivalent length when you're doing flexible vent systems versus the rigid vent systems. And always important with our combustion air is that it's clean, right? So if your boiler room looks like the picture in the middle there, pick another room, because that is basically a lot of off gassing is going to happen and inside that room, even with those containers. And there's potential for, you know, different types of chemicals to actually attack the stainless in the boiler, get into the combustion air side of it, and just create all kinds of problems with the combustion side of the unit, faults, etc. So the whole idea there is that we want to make sure that we're getting nice, clean combustion air and in a room that's not going to basically be harmful to the boiler over the long term. So we're thinking long game here, and we want to make sure that boiler stays in good operating condition. And you can do a lot just by ensuring that that combustion air is clean, and we're not dealing with these types of issues in our boiler rooms. So that is our presentation for today, the 100 B1HE, B1KE application and installation. Thursday, we have the 200. So basically it's going to be a kind of a repeat of this type of layout, but a lot more applications to deal with, because there's a lot more functionality for multiple temperature systems and different types of calls for heat on the 200 versus the 100. So I hope you found this information interesting. And if we have any questions, I think we have some time still to take some questions.
We don't have any open questions. We kind of typed them as we went through, so that can be seen in the question box.
Okay.
But the one question that I had just a minute ago about manuals, when the manuals will be available. Manuals are completed, but we can't release the official documentation until we get sign off from CSA on the documentation. So that's all we're waiting for. All the approvals are done. It's just a matter of getting them to cross the T's and dot the I's and say, okay, now you can go. So we are going to release a brand new Viessmann Canada website in a couple weeks, a week or so. And I think the US Viessmann website gets updated in the beginning of August or the end of July. At that time, by the time those happen, we should have the official documentation on the website. After that, then you're going to have printed documentation available as soon as we can get the printers to print them. And by the time you get manuals, by the time you get boilers on the street, they'll have the right current documentation in them.
Yeah. Excellent. Is that everything?
That's the only ones I have.
Oh,
Unless anybody else has more questions.
Yeah.
Why is there air? That kind of stuff.
Great job, Scott.
Hey, thanks very much, Curtis. Thank you. We'll be doing this all over again next week. So tell your friends that missed this one if they want to take this in, and you can tell them how great the graphics were and stuff on the presentations and how lively the instructor was this morning.
Even though I was asleep.
Yeah, exactly. I do have it's just like the boiler. I have a one-off. It's just not domestic hot water. I have a one-off presentation. So I'm going to go back to bed. And the rest of you guys enjoy your day. And if we, like I say, hopefully we'll see you guys tuning in on Thursday for the 200. And we'll look forward to the startup and commissioning coming up in a couple weeks as well.